Somewhere in the not-too-distant future, an alarm goes off. But this isn't your bedroom. You're inside a pressurized dome on the surface of Mars. And the first thing you notice is that the clock reads something strange. A Martian day called a sol lasts 24 hours and 37 minutes. That sounds harmless, maybe even nice. But your body runs on an internal clock tuned to Earth's 24-hour cycle. Over weeks, that 37-minute drift compounds, your sleep, your hunger, your focus all slowly slide out of sync. But the clock is the least of your concerns this morning. The first thing you do before breakfast, before anything, is check the life support systems. The atmosphere outside is roughly 95% carbon dioxide and less than 1% of Earth's pressure. So the habitat's air recycling system isn't a convenience, it is the reason you are alive. Systems check done now. Breakfast. In an early colony, you almost certainly aren't eating fresh food from Martian soil. Supplies were shipped from Earth months in advance, meaning today's breakfast was packed before you even left. Eventually, hydroponic growing systems inside the habitat could supplement the diet: greens, legumes, things that can grow under controlled light. But that's a best-case later phase. Right now, in this early colony, you eat what was sent. After breakfast, you check the communication window. You cannot call home. The signal between Earth and Mars takes somewhere between 3 and 22 minutes to arrive, one way. You send a message to your family the way someone from another century sent a letter. If something goes wrong emotionally, if you're frightened or grieving or having a breakdown, there is no one on Earth who can respond in real time. That's one of the most underestimated dimensions of a Mars day, the psychological weight of permanent, non-evacuable isolation. Researchers studying isolated, confined, extreme environments, ICE environments, find that interpersonal conflict, anxiety, and motivational collapse are predictable features of long-duration isolation, not rare exceptions. HIC's participants, people who lived in dome habitats in Hawaii simulating Mars missions, described daily life as dominated by routine, confinement, and the slow erosion of novelty. And that was Hawaii, with a rescue helicopter 20 minutes away. Mid-morning now, and the schedule says it's time for your EVA. EVA stands for extravehicular activity, which is the technical way of saying going outside. Before you can step through the airlock, you suit up, a pressurized suit that takes time, protocol, and a second person to check. HIC's participants described the suit-up protocol as one of the most psychologically significant parts of the day, the moment the boundary between safe and dangerous becomes completely physical. Then the airlock cycles and you step out onto Mars. The sky is a pale, dusty pinkish tan, not the deep blue you've known your entire life. And you weigh less than half of what you weigh on Earth. Every step floats a little longer than it should. Low gravity is not a novelty, it is a long-term health threat. ISS astronauts lose roughly 1 to 2% of bone density per month in microgravity, and Mars is just 38% of Earth's gravity, not zero, but not enough. Which is why, every single day without exception, the schedule includes mandatory exercise. But right now you're outside and the EVA has a purpose, a research task, a sensor check, a sample collection. An early colony's scientific mission would likely involve geology, atmospheric sampling, and testing long-term human habitability. The colony itself is the experiment. Then you look up and the sky looks slightly different. Mars has dust storms, and not like any storm you've seen on Earth. That storm killed the Opportunity rover not by destroying it, but by blocking the sunlight it needed to survive. Planet-wide dust storms on Mars can last for months and ground all surface activity. You go back inside, EVA cancelled, and the habitat gets a little smaller. There's something else happening while you were outside, something invisible and constant. Radiation. Mars has no global magnetic field and an atmosphere less than 1% as thick as Earth's, meaning galactic cosmic rays and solar particle events hit the surface directly. NASA Curiosity rover directly measured radiation on the Martian surface, and the numbers are significantly higher than Earth's background levels. Colonies would need to be heavily shielded underground structures, regolith-covered roofs, reinforced walls, and EVA time on the surface would need to be carefully managed and limited. Afternoon in the habitat now. Honest answer, probably a lot like working at a very remote, very high-stakes research station, with fewer options and no way out. Research tasks, data logging, habitat maintenance, these fill the hours. There are maybe 4 to 6 people in your crew, the same 4 to 6 people you see every single day. Researchers studying ICE environments, isolated, confined, extreme, find that interpersonal friction is not a failure of crew selection. There's also the question of what you do when you're not working. Books, films, music, whatever fits on a hard drive. You can send a message home during the evening communication window, and maybe by tomorrow you'll have a reply. Evening arrives, and Mars' evening is something else entirely. That's not poetry, that's the physics of how dust scatters light on a planet with no thick atmosphere to redden the sky. You watch it through the porthole, can't go out without suiting up, and by now you don't have the energy. Now what about the longer picture? Some people speculate that after centuries on Mars, human bodies might adapt: taller frames, larger lungs, lower bone density from generations in lower gravity. Honestly, this is speculation, not science. The interesting science is in what we already know, and the known facts are strange and difficult enough. And what about terraforming, the idea of making Mars fully habitable, turning it into a second Earth? Some public figures, including Elon Musk, have argued Mars can be made habitable. Most planetary scientists consider full-surface terraforming to be a project measured in centuries to millennia at minimum, with no demonstrated feasibility pathway that exists today. The colonists alive in an early Mars settlement won't see a terraformed planet. Night falls now. Outside, it's around -60 degrees Celsius on a mild night. Inside the habitat, it's controlled, warm, the thermal systems are running, you hope, without a problem. You do the last system check of the night: oxygen levels, pressure, temperature. All good. You lie down. Maybe about the people you messaged who haven't replied yet. Maybe about how the blue sunset looked. Tomorrow, another sol.